we're going to look at formulas today to um, to add two triangles together and then to find the ratios of the new triangles. So I built you something. If you go to the notes template, this is a link to a Desmos calculator that you can play with. So what I have here is triangle A has the cosine of 0.866 and the sine of 0.5. So triangle A has a 30-degree triangle. And then triangle B is a 60-degree triangle. So if I want to find the sine of 30 plus 60, that would be the sine, basically the sine of 90. What I want to know is, will the sine of 60 plus the sine of 30 equal 1? And I can see that 0.866 plus 0.5 is going to be greater than 1. So this formula doesn't work. So what I have is the sine of one angle plus the sine or the vertical height of the next angle will not equal the sine of the two angles added together, the new triangle. Okay. So what do? We have all these formulas for us called sum and difference formulas. So if I have two original triangles that I'm trying to add together, add the angles together, the new ratios will be equal to these formulas here. Okay, so write them down, and then we're going to do an example here. All right, so we're going to find the exact values of sine, cosine, and tangent for negative pi over 12. So first off, we need to figure out a sum or a difference. So negative pi over 12 will equal some angle A plus or minus some angle B. Okay, so I know that 2 pi over 12 minus 3 pi over 12 is equal to negative pi over 12. And when we reduce that, that is going to be pi over 6 minus 4 pi, or pi over 4, which is cool, because these are from our special angles, okay, which we know a lot about those. So we're going to use this setup here, pi over 6 minus pi over 4. So we're going to straight substitute, so we're going to find the trig ratios for negative pi over 12. So if I look at the triangle, that's going to be like right here. That's basically negative 15 degrees. We don't know much about negative 15 degrees, but I do know a lot about pi over 6 and pi over 4. So we have formulas to help us solve for the new angle. Okay, so we're going to call this angle A and angle B. I know from above that the sine of A minus B is equal to the sine of A times the cosine of B minus the cosine of A times the sine of B. Okay, so up here I'm going to be like the sine of pi over 6 times the cosine of pi over 4 minus the cosine of pi over 6 times the sine of pi over 4. So let's evaluate these. Sine of pi over 6 is 1/2. This is root 2 over 2 minus cosine pi over 6, root 3 over 2, and root 2 over 2. Okay, giving us root 2 over 4 minus root 6 over 4, which is equal to root 2 minus root 6 all over 4, and that's it. So that is the sine ratio for, so that's the sine ratio for this triangle. Okay. So we're going to go ahead and figure out the cosine. I'm going to erase this. Okay. Same idea, but we're going to figure out the cosine. So the cosine of A minus B is equal to, these are cosine, cosine, sine, sine. So cosine A, cosine B plus sine A, sine B. So angle A, angle B. Cosine of pi over 6 minus pi over 4 is equal to the cosine of pi over 6 times the cosine of pi over 4 plus sine of pi over 6 times the sine of pi over 4. Okay, so that equals, we get cosine of pi over 6 is root 3 over 2 times the cosine of pi over 4, root 2 over 2, plus the sine of pi over 6 times root 2 over 2, okay? And that equals root 6 over 4 plus root 2 over 4, which is root 6 plus root 2 all over 4. So this would represent the x length of the negative 15-degree triangle. Okay. All right, lastly, tangent. Tangent is the tangent of A minus the tangent of B all over 1 plus tangent A, tangent B. Just make them all caps or all lowercase. Okay, so A and B. So the tangent of pi over 6 minus tangent of pi over 4 all over 1 plus tangent of pi over 6 times the tangent of pi over 4. Are all of these inputs angles or ratios? They are all angles, guys. Okay, so what ratio do I have at pi over 6? What tangent ratio? I have root 3 over 3 minus tangent at 45 is 1 all over 1 plus root 3 over 3. Okay, and this is gross, so let's multiply on the top and bottom of this fraction by 3, giving us, I'm going to have to distribute it in. So root 3 minus 3 all over, again, distribute 3 plus root 3, and we're going to leave it like that. Okay, so that's one example of our how we use sum and difference formulas. Let's do one more. Okay, so we're going to find the exact values of sine of u plus v, and here's our given information. Sine of u is 4/5, and the angle is between 0 and pi over 2. So, if our triangle wasn't in the first quadrant. So it looks like our sine is 4/5, and since this is a right triangle, and I remember my Pythagorean identity, or triples, this is a 3, 4, 5 triangle. And so given that information, I'm also going to figure out that the cosine of u, of this angle u, is 3/5. I'm going to use that later. Okay, now I get a second piece of information here, that the cosine of v is equal to negative 12 over 13, and this is in the between 90 and 180, so this is the second quadrant. So draw that in. So v is equal to negative 12 over 13. And because I remember my Pythagorean triples, I know that this is a 5, 12, 13 triangle, but you can also use the Pythagorean theorem. So I know the cosine. I'm going to write down my sine. It's 5 over 13. The sine of v is 5 over 13. Okay. So now I can just solve. The sine of u plus v, this is a sum of angles. So we're going to use sum and difference formulas. So this would be the sine of u times the cosine of v plus the cosine of u times the sine of v. So the sine of u plus v, we don't know the actual angle measures, but I know all the ratios, so I can figure out the ratio of this new sum here. So the sine of u is, let's see, 4/5. The cosine of v is negative 12 over 13. The cosine of u, 3/5, and the sine of v, 5/13. So that equals negative 48 over 65 plus 15 over 65, which is negative 33 over 65. So the ratio, when I add angles u plus angle v, we get a sine ratio of negative 33 over 65. So it's going to be either in quadrants 3, the new angle is going to be in either quadrants 3 or 4.